In this video lecture, we will continue finding the limits of other indeterminate form, these five forms. Let's take one example. Finding the limit of this. When I put x is equal to 0, this gives me infinity, this gives me infinity, that is, you have this form. But here, since it is infinity minus infinity, I cannot use the L'Hopital's rule for this, because L'Hopital's rule has to be used only when you have expression 0 by 0 or infinity by infinity. So what I will do, I will not use L'Hopital's rule for this. First, I will cross multiply. That means I just subtract these two. So cross multiplying these two, we have this. Now I put x is equal to 0. When I do this, I get 0 by 0. Now I will use the L'Hopital's rule. Look at it. Here I am not using because infinity by infinity. So it is not, I cannot use the L'Hopital's rule here. So I simplify. Then if I get 0 by 0, then I will use. So using the L'Hopital's rule for this, not for this. So I have this. So I find the derivative of this, it is this. Then for this, I will use the product rule because the first function, the second function, I have this. Now again, I put x is equal to 0, we get 0 by 0. But before that, we will do some simplification. So what I will do the simplification. That means I will cross multiply this. So x plus 1 minus 1, there is a denominator x plus 1. Then I cross multiply this. So x plus this into x plus 1. So x plus 1, this denominator x plus 1 cancels. I get this. Okay. So plus 1 minus 1 cancels. You get x. And this is as it is. Now still again it is 0 by 0. So I will use the L'Hopital's rule again here. So derivative of x and then derivative of this. So derivative of x is 1. So derivative of x, this is 1. Then this and this product rule I will use. You see, this is the product rule for that. Now I put x is equal to 0. So ln 2 is 0. So here we have a ln 1 is 0, sorry. And then when I substitute all, I get 1 by 2, the answer. So note this, you need to do the sum simplification, otherwise this will go on remaining as 0 by 0. So you need to do some simplification. That means I will subtract and then cancel x plus 1. Then I will be able to get the limit here. Another example of the form 0 into infinity. So if I put x is equal to infinity, infinity into, 0 into infinity you have. So what I will do, this is multiplier, so I can take ln x into 1, so I can write in this format. Now you see earlier it was 0 into infinity form. Now when I multiply ln x into 1, it becomes ln x by x. Now I put x is equal to infinity, it becomes infinity by infinity. So now I will use the L'Hopital's rule for this, not for this. So when I use this, I find the derivative of the numerator, denominator separately. Derivative of this 1 by x, it is 1. So put x is equal to infinity. This is 0. 0 by 1 is 0. Answer. In some of the examples, let's take the other three now. 0 raised to 0, infinity raised to 0, 1 raised to infinity. If you get any three of this, then you're going to use this method. See, apply ln both the sides, ln y, ln. Then according to the laws of logarithm, this gx becomes multiplier, so gx into ln fx. Then find the, what you call, the limit of this and continue. Here an example, the indeterminate form of 1 raised to infinity. You see this. So when I put x is equal to 1, so 1 raised to 1 by 0, that is 1 raised to infinity you have. So what I will do, I will apply ln I take ln both the sides. See, this is y equal to x raised to 1 upon x minus 1. So I take y equal to this. I take ln. So leave this limit first. Only you take the function, apply ln. So this is become multiplier. So 1 upon x minus 1 x ln x. Now you take limit both the sides. After ln, you take the limit. So limit of ln y, limit of this. So now you see, you put x is equal to 1. So 1 upon x minus 1 is 0. Sorry, infinity, ln 1 is 0. So it is infinity into 0. So I cannot use the L'Hopital's rule. But I can multiply ln x into 1. So it will become this. Now you put x is equal to 1. It becomes 0 by 0. Now I will use the L'Hopital's rule. So to differentiate the numerators, denominators separately, I have this. So now you put x is equal to 1. So it is 1. I get the answer. But you look at it, this 1 is for ln y. So what I will do now, I write limit of y x tending to the limit of e raised to ln y, so that I will be going back. That means I will have to cancel this. You know that e raised to ln y is y. So therefore to cancel, this is the extra I have taken to find the limit. So I need to cancel this. So I will take e raised to ln y. So ln y I got here, ln y I got 1. So e raised to 1. So e raised to 1 is the answer, not this. Because this is for ln y. So ln y I have taken extra because it was not here. So to cancel this, so I need to find the limit of y, because this is the limit of ln y. This is the limit of ln y. So to find the limit of y, I will take the inverse of that. So e raised to ln y. So e raised to 1 is the answer, not this. So this 1 is the limit of ln y, and this e is the limit of y. Similarly, we have examples from 0 raised to 0. In this example, we have here 0 to 0. So what I will take? I will take the function, right? So y is equal to sin x by x power x. Take ln, the multiplier, then take the limit for this. Then I have this. So then I will rewrite this because it is 0 into infinity. Now I cannot use the L'Hopital's rule here. So what I will do here is I will take this x, I will write as 1 by x. So now it becomes infinity by infinity. Then I will use the L'Hopital's rule. I need simplification here. Otherwise it will remain as it is. So derivative of this and this, I have this. Again you have infinity by infinity. So what I will do, I will just multiply the numerator and denominator by x square sine x. So by doing this, I will get this expression. So why only this? Because if you do this, then it is easily we can find the limit. Otherwise, it is not. So you need to check it out. How best? I mean, what is the best way of finding the limit, and what you need to do the simplification. So I will do this. Then I have this. Again, it is 0 by 0. I will use the L'Hopital's rule. See, I find the derivative of this, then I get this. Now I put x is equal to 0, get 0 by 1 equal to 0. Now this 0 is the limit of ln y. So I have to cancel this ln. So I will take e raised to ln y. So ln y is 0, e raised to 0. So e raised to 0 is 1. So this 1 is the limit of y, and this 0 is limit of ln y. But this is the answer, not this. So another example for infinity raised to 0. You see here the same. Again I will take the function, right, and then I will take the limit. Then I have this. Now you see this is 0 into infinity. So what I will do, I will multiply here. I cannot use the L'Hopital's rule because it is 0 into infinity. I had to convert either by 0 or infinity by infinity. So therefore I will multiply these two. I have this. Now it is infinity by infinity. So I differentiate. I have this. Okay. Now I put x is equal to infinity. Then 2 because 1 upon this is 0. Then here this can be brought down. It is x plus 1. So now I put x is equal to infinity. So 2 divided by infinity is 0. So this is the limit of ln y. So therefore I take e raised to ln y, e raised to 0. This is 1. So this is the limit of y. So these are the examples of finding the limits using the L'Hopital's rule. So almost all the example we have done in the lecture note, and more example we will do it in the live class in week number 7. So these are the answers, and what we have studied in week number 7 second part. Here we have studied 7 different indeterminate forms in mathematics, and then how we find the limit of indeterminate forms. I mean these indeterminate 7 indeterminate forms of the function using the L'Hopital's rule. So that's the end of the last part of week number 7. Thank you.